Okay, here we have another shark on the ocean by the name of trigonometry. Let me take you through the series where I will be helping you to show you how to prove or how to solve trigonometry problems. The problem for today rises from grade 11 trigonometry. So here I'm required to determine the value of the following without use of a calculator. So the fact that they specify that I have to find a value, meaning this expression should reach to the point where it becomes a number, which is a value. Alright, the fact that I have this angle is 180 degrees minus x, 360 plus x, 90 degrees plus x. The thing that will guide me in order to solve this problem is my cast diagram. Okay, here is my cast diagram. Okay, before we even write everything, here is my cast diagram. Okay, this is a Cartesian plane where this one is y-axis, this one is x-axis. Okay, on my y-axis, if I'm labeling them according to degrees, so here become 90 degrees, here it's 0 degrees, here it's 180 degrees, here it is 270 degrees, here it's also 360 degrees. So here this is required to a first quadrant, it's a second quadrant, it's a third quadrant, and a fourth quadrant. So judging from here, moving from this side where there's an angle of when my angle is theta. Okay, here it's my x, here it's my y, here it's my r. Okay, if you can look carefully here, this is your first quadrant. In your first quadrant, you see that your x, your y, your r, they are all positive, which give rise to sine theta being equal to y over r, that is positive, cos theta being equal to x over r being positive, and then tan theta being y over x. Okay, tan theta being y over x, this one is also positive. So you can see that in your first quadrant, sine, cos, and tan, they are all positive. So moving this side, you know that here you have minus x. So we now look at this side. Okay, so in this side here, I have y is positive, here x is minus, and r is positive. So if you look carefully here, your sine becomes y over r, which is positive. Your cos, okay, theta, your cos theta becomes minus x over r, which makes it be negative, and then your tan theta becomes y over minus x, which makes it be negative. Moving this side, my angle was here. So here I'll be having minus y. So it's minus x, here it's minus y. So tan theta will be minus y over minus x, which makes it y over x, which makes it be positive. And then sine theta here will be minus y over r, because here it's r, or which makes it negative, and then cos theta will be minus x over r, which makes it be negative. Moving here to the fourth quadrant. Okay, here we have r, here we have minus y. So if you can look carefully here, for cos theta we have x over r, it makes it positive, and then here for sine theta it becomes minus y over r, it makes it negative. For tan theta it becomes minus y over x, it becomes negative. So you can see now that first quadrant, they are all positive. Second quadrant, they are negative except for sine. Sine is positive here, tan is positive here, and cos is positive here. So going back to this expression, so here we have tan. In 180 minus, we are looking at this portion. It's 180 minus, meaning we are reducing from 180 to, you are approaching 90. So this is the second quadrant. On the second quadrant, what is the sign for tan? Tan is negative. So it becomes negative tan x, because the quadrant is the one that gives you the sign of the trigonometric ratio that you are referring to. So where is 360? 360 moving this side, you are reducing. But 360 moving up, you are incrementing, because here it's also 450 degrees. So if it's 360 plus, that means we are referring to the first quadrant. And the first quadrant in this scenario, cos theta is positive. So here, cos 360 plus x is equal to positive cos x. All over, here I have 2. All right, there is this special identity that says when you have cos of 90 degrees minus x, it becomes sine x. So when it's cos 90 degrees plus or minus, but the cos changes to being sine. If we have cos and we say 90 degrees plus x, look carefully here on your cast diagram. From 90 degrees plus, meaning we are referring to this quadrant. In this quadrant, cos is negative, but cos will change into being sine. So the quadrant is the one that determines the sine, and 90 is the one that changes the cos from being cos into being sine. So here, if we are referring to cos into 90 plus x, it will be equal to minus sine x. We are not looking at sine, we are looking at cos. So we start by looking at this one. This one will direct us to the quadrant. And we go there to that quadrant, we check the sign for this one, trig ratio. So the sign for cos in second quadrant is negative. But we know that if we have 90 plus or minus, cos changes from being cos to being sine. So as a result here, we'll end up having it's minus sine x. So we have minus tan x times cos x over minus 2 sine x. All right. In this scenario, we know that tan of theta is equal to y over x. And we know the tan of theta is equal to sine of theta over cos of theta. Meaning here, instead of leaving tan here, I can replace tan x by sine x over cos x times cos x all over minus 2 sine x. So cos x and cos x divide, I'm left with minus sine x over minus 2 sine x. So the 2 divides, I'm left with 1 over 2. So the solution to this expression is 1 over 2.
Hi, also.
Hello.
Sad boy, Dad. Hello.
I'm balancing. I'm greetings.